there. Hello there. Today we'll be doing word search number 2. This is going to be a very difficult problem. You might see me relying on notes this time around. So I haven't been relying on notes for a lot of the problems in the second round, but I think this might be one of them. Okay. So first things first, what we're going to do here is if we do this in the normal way of doing word search, we're going to do it in O of n times m time, because we're going to start at every particular point. And at every particular point, we could go 4 directions. But to be exact, we can go 3 directions, n times m usually. And we'll do this for every single word. So it's 3 to the n times m times n times m. But if you use a try, we can remove number of words to once, because let's say we have oaf, and we have oaf, and we have oat. We can just do this in one try, and we don't have to repeat the same work over again, as long as we build the word up, as long as the word exists in our try, right? So we can knock out 3 words. We can get three words in our results. Right? So with that, we can simplify the problem. Okay, so first things first, one thing to note is that we do need to prune the tree to make this efficient, because we don't want to go down the same path after we're done with it. That's just like using a set, so it's completely useless. So we do have to use a pruning method, and we will be writing all of that up right now. So let's just create a class called trinode, define underscore init underscore self. This creates a trinode, and self.children equals default dict trinode. This makes it easiest for us to create, and is end or is word also works. Let's try is word. I like that more now. Okay, let's define add word. Let's take in self. Let's take a word in. So cur equals self. Word cur equals cur.children at this particular char, and then we're done. Word sure equals dot is word equals true. Done with add word, and now time to do prune the word. To prune the word, we do need to do this in reverse. So basically, we need to be able to find oafs, like this one right here, and we need to go to the last item. So if we see oaf and we got that, this is not a word that we should prune, because we still have oafs. So we gotta check until the last word, and check that does that item, this item here, have children. If it does not have children, when that means we can prune this word. So and then we can check the parent node. Each parent node, after we prune this item, we can start pruning this item. So this parent checks its children for that particular key, and if it doesn't exist, if it does not have any children, then this becomes destroyed, and so on and so forth until we have nothing left, and that means there's nothing to check, which is great. So cur equals self, and we're going to create this parent node and child key, which is equal to well, this is going to be a list of tuples where we have our trinode and our string of items that are called our a key, a child key. So this is going to be equal to an empty array now. So for character in word we're gonna create our parent node and key now. So parent node key dot append. We're gonna put this try node in, so this cur spot and this character. So this item here is looking at current, which is here, this empty spot, and we're looking at O, A, T, and H. Okay, anyways, so then we have this character here. This is the current, and this is our item. So cur is equal to cur dot children at this particular char. So we are now here, and this once we're at O, we're gonna look at A, and we're gonna look at T, and we're gonna look at H. So this gives us a the parent looking at the last item. So for parent node and child key in reversed of this parent-child key, what we're gonna see here is target node is equal to the parent node dot children at child key. So this is our target node. Right there. If target length of target node not children is equal to 0, then we can delete our parent node dot children at the child key. So we were here, 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 and we're pointing at this last item. So this parent node points to this particular key, right? We'll check that. We'll check that. So with that, we can delete, else we're gonna return. And with that, we have proven the word. All right, now we're ready to find the word. So how we're gonna do this is that we're gonna do for R in range of rows and for C in range of columns, and we're gonna run a DFS call on the rows, the columns, and this particular node, which is gonna be called root, and we are going to run this on the empty word that we're gonna build up. So root is going to be equal to, try node. And we're going to create that. So for word in words, root dot add word of word. So we're going to add all of these words into a try node. Perfect. Next, we need rows and columns. So rows, columns equals length of board and length of board at 0, which is going to be number of columns. Okay, great. We also need when we do our DFS call, we do need to know where we have visited, and we need to keep track of the results. So we're going to get the results, and we got to get the visited equals a set. Perfect. With that, we can run the DFS call and fill in our results and return our results. So let's create our DFS. In our DFS, row, column, node, and a word. So right. So that's our current word. We're gonna have to do a if row is less than 0, or row is column is less than 0, or row is equal to rows, or column is equal to columns. We are out of bounds. We don't want that. Or the board at row and column, this particular character, is not in our node, not children, so it can't go forward. Or this it's visited, so R and C in visited. With that, we can return. Otherwise, we'll continue. So while we're continuing, let's think about how to do this. So we're going to build up our word. So if node is a word, so how are we going to make a node is word? Well, node equals node.children at this particular character board at R and C. Our current word is going to be equal to plus equals this particular character, and we are going to check if this is a word. So if it is a word, then we want to add this to our results. We also want to prune. Actually, we want our self.root.prune. Not sure actually how to do prune word. Give me a moment. Alright, so let's prune that word. So it's not self, it's just root.prune word. And we're going to prune this particular word. And also, we need to just make sure it's false. So so node.isWord is equal to false. Of course, we need to make sure this happens before the pruning of the word. And one more thing is that I forgot. It's visited is equal to add. We need to add this particular row and column. Once that is done, we create the word. We visited is added, and that should go actually here after all of this. And now with that done, we are ready to just keep on visiting all the DFS calls. So DFS, row, column, this particular node, and this particular word. I think this node could be better called cur, but we can change that later. We can do r-1, r+1, c+1, r-1. Of course, when we're done with this, we must remove visited so that we can revisit that particular location. With that, I think this is the complete code, and we can return. There seems to be an issue here. Board. collections, default dict, object not callable. Oh, right. Run. All right, everything looks good. Let us return. Oh, wow, great. We got it this time. Perfect. No issues. So that is how we do word search number 2. A pretty difficult problem, as you can see. We had to build up our word and make sure it matches throughout the matches our try branch, and just going through our DFS calls. And the hard part was pruning the item, which was up here. I can't fit the entirety of this code into this particular, window. What I can do is that I'm going to leave this code inside the description so that you can check it out and use it for yourself and not need to copy it with difficulty. And with that, if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. And thank you very much. If you have any questions, please comment, and I'll see you in the next one. Bye.